Hi, welcome to an audio test session with APX. These videos provide worthwhile information for APX users and demonstrations on a range of audio measurement applications. In this session, Mike will discuss and demonstrate loudspeaker test methodologies.
The APX 500 measurement software can be run in two modes, sequence mode and bench mode. We will be using sequence mode for the following demonstrations. The sequence mode UI is comprised of four main panels. From left to right is the navigator pane, the signal path setup pane, the results display, and in the lower left corner a set of monitors and meters. The navigator pane controls which tests will be performed and in which order. The signal path setup pane defines the connections to be made for a specific signal path and the instrument settings. The same pane can also be toggled to show and control individual test-related settings. The results display on the right side of the screen shows all of the measurements made, which may be meter-type measurements, may be plots, or a combination. The lower portion of this area shows a thumbnail view of each specific result available from the running of a single test. For this test, I've configured a ground plane test on a table in a semi-anechoic chamber. In this case, the floor is reflective. To set up a new test, start with the standard APX 500 project. Click on the Add Measurement button and select the Acoustic Response Test. Click on the Add and Close button at the bottom of the Add Measurement window. In the Navigator pane, scroll down to the Acoustic Response step in the sequence and click on the checkbox to the left of that test. If we scroll down to the bottom of the sequence, there is an item called Report, which we will unselect just so that it isn't popping up each time we run the test. Next, we will set up the signal path. By clicking on the left arrow, we will shift the view in this pane from the test setup to the signal path setup. We will start the signal path setup with the output configuration. Since we are using the APX 1701, we need to set the output connector to transducer interface. We are only testing a single driver for this test, so we will set the channels control to 1. We will be using amplifier input 1, so click on amplifier 1 to turn it on. Leave the acoustic box unchecked. Scrolling down to the input configuration section, we need to first change the connector to transducer interface. We have only one input, the microphone, so we set channels to 1. Again, leave the acoustic box unchecked. The values for the next three items in the list can be left to the defaults. Since we are using an unbalanced measurement mic, we need to turn on the constant current power supply. We are going to be using dB/SPL units, so set the unit at the top of the results graph for RMS level to dB/SPL1. Next, we download the TEDS data from the mic. Click on Set dB/SPL, then click on Calibrate from TEDS button in the pop-up window. This opens a secondary pop-up window. Click on the Read TEDS button. Once the TEDS data is displayed, click on the Set Sensitivity button, then click on Close, followed by closing the mic cal window. We will now set up an output reference. Setting a value here propagates to other controls that need an output level setting. Make a mental note that the dB/RG box is initially set to 100 mV RMS. Under the Analog tab, scroll down to the Auto Gen Level button and click on it. When the pop-up window appears, set the Regulate pull-down to RMS level. Using the Target Value pull-down, select dB/SPL1, which automatically enters 120.775 value into the box. Then edit that value to 94 dB. Next, we will set the range that the analyzer uses as the bounds for the automatic level search that will find the 94 dB/SPL level. The first time you do this, you may find yourself having to empirically arrive at good values. In this case, I've determined that a 1 volt start and a 3 volt stop setting does an efficient adjustment. Also, it seems that an initial steps setting of 3 sometimes works a bit better. Once these settings have been made, click on the Start button. This begins the automatic output level adjustment. You can see that the system arrives quickly at the 94 dB SPL setting, which is displayed on the right side of the screen as the measured level. Note that the dB/RG box in the reference section now shows 1.429 volts RMS, which is the output voltage necessary to achieve a 94 dB SPL for this particular setup. Note also that the Verify Connections level has been automatically set to that same value. This completes the signal path setup. Next, we have a couple of settings to make in the acoustic response test settings. Click again on the left arrow at the top of the signal path setup pane and go back to the measurement settings. Here we need to set the level that will be used for the sweep to 0 dB/RG. This specifies that the sweep will be done at the RG level, which we have set to 94 dB. At this point, we have made the necessary settings and we are ready to run the sequence. Click on the blue Run Sequence button in the Navigator pane to start the test. Once the test completes, the measurement data will be shown in the Results section on the right side of the display. Note that each result can be selected below the graph, showing the data for each measurement made. You may find some of the data displayed is off the graph. This can be addressed by simply auto-scaling the data. To do this, hover the mouse pointer just above the end of the y-axis title, which causes a small down arrow to appear. Click on this and then scroll over and click on Auto-Scale. Note that the single sweep produced all the measurements shown. Frequency response, THD, rub and buzz, and other measurements were all measured simultaneously. If you prefer to have the level adjusted at the beginning of each run, click the Measurement Sequence Settings item just below the signal path setup line in the Navigator pane. This opens a pop-up window. Click on the Auto Set Generator level under the References column. Once you have completed this setup, save it as a project or template file under the menu item File using Save Project As, and assign the file a meaningful name. The next time you need to run this test, simply open that project or template file and all of the setup will be done automatically. I talked about floor bounce earlier in this video. I've reconfigured the test setup to be a standard far-field configuration with the same driver and the same measurement mic that we have been using, but now configured for elevated far-field testing separated by 2 meters in the same semi-anechoic chamber used for the previous measurements. I also used the same acoustic response project that we just set up. A quick click on the Run Sequence button produced a set of new results. In the impulse response plot, you can see a ringing in the response a couple of milliseconds after the impulse. This is the acoustic signal bouncing off the chamber floor and arriving at the mic a bit later than the initial impulse. Looking at the frequency response, we see that the response now has significantly more aberrations compared to what we have seen with this same DUT previously. As a first step, we will adjust the windowing to cut out this reflection using the impulse response view. After making this change, the frequency response plot above 1 kHz looks a bit more normal, but we see that the lower frequency range is quite different. Note that the energy time curve provides better resolution to the reflection edges than is shown in the impulse response plot. This view shows just how close to the initial impulse the reflection really is. We cannot expect to get a good representation of the low frequency range with this configuration. This particular setup in this chamber is not the best choice, which is why I've been using the ground plane technique in the chamber up to now. Next, let's go back to the ground plane configuration, but this time test using Loudspeaker Production Test measurement set. This setup is quite similar to the setup for acoustic response, so I will focus only on the differences in the setup compared to acoustic response. In the Navigator pane, you can see that I've added a second signal path. This allows me to keep the acoustic response test unchanged in the same sequence. After adding the new signal path, I added Loudspeaker Production Test measurement using the Add Measurement button. Now we need to set up this new signal path. With the Loudspeaker Production Test measurement highlighted, go to the Signal Path Setup pane and click on the left arrow to get to the signal path setup. The output settings are the same as acoustic response. There are a couple of changes in the input configuration. We are still using the transducer interface, so that is still selected. However, now we have two input channels. One is the measurement mic and the other is the current sense signal to measure the speaker impedance. Set channels to 2. From here, we toggle the left arrow in the signal path setup pane to get to the measurement settings. We need to scroll down to the analyzer settings. The test configuration should be set to external 1 channel, and the channel sense should be set to channel 2. The test setup is now complete and the test can be run by clicking on the Run Sequence button. However, we saw this in action in the beginning of the video, so I won't repeat it here. Next, we'll set up to test a Bluetooth speaker. Starting with the standard APX 500 project, we need to add two measurements. One is DUT delay and the other is the acoustic response. Once that is done, move to the signal path setup. This time, we will not be selecting transducer interface for the output connector. Instead, we will select Bluetooth. Turn on your Bluetooth device and place into pairing mode. Select Bluetooth in the connector pull-down and then click on Scan. This starts the scan for your device. Once complete, the scan table will contain any devices found. Click on your device and then click on Pair. In the pop-up window, click on Pair Device button. Once complete, close the scan window. Next, click on the Connect button and select your device. A short pull-down menu appears. In this case, I will be using the A2DP profile. The Bluetooth setup is now complete. From here, we move down to the Input Configuration section. Since we are still using the measurement mic, we will use the transducer interface for the input connector. Set channels to 1. Turn on the constant current power supply. Next, set dB SPL and go through the same procedure that you used with the previous acoustic response setup. In the pop-up window, set units to dB SPL1. Click on Calibrate from TEDS. In the new pop-up window, click on Read TEDS. Once the sensitivity data shows, click on the checkbox for Set dB SPL1, then click on the Set Sensitivity, and then click on Close. Finally, click on the Microphone Calibration Close button. Moving down to the Reference section, select the Digital tab. Click on Auto Gen Level. Once the new window opens, set Regulate to RMS level and target value to 94 dB SPL. The start value of -60 dBFS and the stop value of 0 dBFS are OK. Set initial steps to 3, then click on Start. The system will now auto-set to 94 dB SPL. You can see that in the reference level and verify connections levels have now been automatically set to -14.766 dBFS. Moving back to the navigator pane, make sure that the DUT delay and acoustic response checkboxes have been checked. At this point, we have completed the configuration and can now run the test. Click on the blue Run Sequence button. Note that the DUT delay measurement shows 167 milliseconds, but the acoustic response data is nonsense. This is because of that 167 millisecond DUT delay. We must go into the acoustic response test settings and change the DUT delay to 170 milliseconds. Note that the delay can move around a bit, so it might take an adjustment or two to find a reliable value. However, as soon as we make this change, the next run of the test produces a quite good data set. The frequency response is quite flat over the range of about 200 Hz to 9 kHz. With that, we've come to the end of our testing. Thanks for watching this edition of Audio Test Sessions with APX.